Now let's talk about continuous distributions. In this section, we're going to discuss two types of continuous distributions. First, we'll talk about what a uniform distribution is, and then in the following video, we'll discuss the standard normal distributions. Let's talk about uniform distribution. A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. So let me show you what that looks like. Let's say we graph the random variable x, and it has values between 123 and 125. And then on the y-axis, we'll graph the probabilities, or p of x. Let's say that every single random variable x has a 0.5 chance or a 50% chance of being chosen. Every single x value between 123 and 125 has an equal chance of being chosen. This would be a uniform distribution. One thing to notice for all probability graphs is that the area underneath the probability curve is always equal to 1. I hesitate when I say curve. I understand that's a line. A line is a type of curve. So the area underneath our probability curves is always equal to 1, whether we're talking about uniform distributions or next section when we're talking about normal distributions. The graph of a continuous probability distribution is called a density curve. And again, I'm using the term curve loosely. Our curve is that straight horizontal line at 0.5. These are called density curves. Let's do an example. So let's suppose that this graph right here illustrates the following. A company manufactures power supplies, and the voltage level of any given power supply is uniformly distributed between 123 volts and 125 volts. Find the probability that a randomly selected voltage level is greater than 124.3. Okay, so what we have here is basically this section right here at 124.3 volts or larger, the section that's shaded in a dark blue. Those would be all of the randomly selected voltage levels that are 124.3 or greater. Well, to find that probability, we basically need to find the area of that blue rectangle. Fortunately, it's a rectangle, so all we need to do is find the base times the height. So the probability that our randomly selected variable is greater than 124.3 is base times height of the area that's to the right of 124.3. Well, the base we can figure out by subtracting 125 minus 124.3, and the height for every single variable in there in the probability curve is 0.5. So our base times height turns out to be 0.7 times 0.5 or 0.35. So what that means is there is a 35% probability or chance that a randomly selected voltage level is greater than 124.3. Let's do another example. Let's suppose a subway train in New York comes every 5 minutes. A passenger has to wait X minutes for a train where X is somewhere between 0 and 5 minutes. First, let's find the probability of waiting longer than 4.37 minutes. This one's a little bit more challenging because in this one, they didn't tell us what the top of that probability curve is, so we don't know the height of our rectangle. But we can figure it out. Remember that the area underneath any probability curve has to be equal to 1. So to find the height of that rectangle there, we can find using the fact that the base times the height gives us the area of a rectangle. The base is easy to calculate. That would just be 5 minus 0. And the area has to be equal to 1. So if we have 5 times the height equals 1, then the height is equal to 1 divided by 5, or 0.2. So now we can label the height of that probability curve as being 0.2. And we'll use that to finish the problem. Okay, so if we're finding the probability of waiting longer than 4.37 minutes, and our height is 0.2, we know, then we need to find the area to the right of x equals 4.37. Again, happily, this is a rectangle, so we're going to find it using base times height. So the probability that x is greater than 4.37 is base times height. So 5 minus 4.37 times a height of 0.2 gives us a total, I'm sorry, of 1.26, or 0.126. Now let's find the probability of waiting less than 1 minute. So that would be this rectangle right here to the left of x equals 1. So the probability that x is less than 1.0, the base of the rectangle is 1 minus 0, or 1. The height again is 0.2.